Okay, good morning, everyone. During this session, you are going to learn about Newton's laws of motion, or in specific, the first law. But before going to the first law of motion, there are just some concepts that must be made clear to you for you to further or better understand the implication of the first law. Now, the first thing that you have to understand well prior to discussing about the first law is the concept of the superposition of forces. Now, this is not a completely new topic to you because we have dealt with vectors, and basically, what we are dealing with vectors, particularly if you remember class, this is very familiar to you, the R vector, which is the resultant vector. It is something that will be seen continuously in this discussion. Now, as I've said, we will talk about the superposition of forces. Now, unsa may giingon sa superposition of forces? Now, according to the text here, any number of forces, that means you could either have one force acting on the body just like this one, or another force, force 2 acting on the same body. So naa kay any number of forces. In this case, we are dealing with a simple case where we have two forces acting on the body. Unsa may implication ana when you have daw any number of forces acting or applied at a point on a body, as long as it's acting on the same point on the same body, ang kanang duha ni mga force class, it seems to have the same effect as a single force. So murara daw kang effect ng duha ka forces under the principle of superposition. Murara na siya isa ka force ang gi-apply nimo as long as kanang katong isa ka force is equal to the vector sum of the forces. Or in another words, kanang gipasabot na to na vector sum, that is just the resultant vector. Now in this case, since we are dealing with forces, ang atong resultant vector is appropriately called our resultant force. So, sa Bisaya pa, bahalagdaghan kay ka nga force gagaak sa imong body, which would make the analysis of the problem complicated. Kaya daghan kay sir, 5 ka force ang gaak. Pero class, ang bottom line na niya is you just have to find the resultant vector R, because according to this principle, bahala pagdaghan kayong forces, kinaingon din no, any number of forces apply sa body, it will always seem as though isa lang ang force ana. The effect, the same effect as though a single force is acting, as long as ang single force nga gaak ana niya, or it seems as though katong single force nga gaaka na niya is the resultant vector or the resultant force of all the number of forces nga gaak niya. So this is very important in the analysis of physics problem. Okay, for example, na ako'y other force dito no, nasa J force pasaka. Okay, I'll just have to, there's something wrong with that. Okay, batantar na ako'y force ani diri class. So, butang ako no, F3. Butang pag yun na pag force isa ka string, butang tag string ang force ang gadala sa force ana niya. So na ako'y F4 ana niya. So syempre this is quite complicated, right? But again, this will be simplified by only finding the resultant. So pangitaon ako ng resultant vector anang upat ka forces. May highlight ang forces no in different color like F2, F1, F4, F3. I will just find the resultant force or the resultant vector, and then I will analyze the problem using the resultant vector. Ano man, because according to the superposition of forces, it seems as though it has the same effect as a single force, and that single force there is your resultant force. So again, that principle is the superposition of your forces. So it helps us simplify things. Instead of dealing with all the forces, we will only deal with the resultant vector or resultant force. That is why the very first thing yun na atong gidiskussan sa atong class is to find for the resultant vector for reasons nga isa ni sa reason. Okay, always na mag-deal with resultant vectors. Okay, so another concept that you have to understand is the concept of net force or resultant force. Again, this is just the same thing or closely related with the previous slide and also with our previous discussion. Now, take for instance, you are pulling the Okay, you are applying the force on this box at the same point, meaning at point O. So you're trying to pull the box towards the um, right direction, or your kining x nimo class ba. So towards the right direction, and that is your force F sub x. At the same time, gipull sab nimo, you are pulling the box at point O upwards. Yan ang padulong sa y, that is your force F sub y. Now, as you are seeing there, unsa gani atong giingon ani sa atong superposition of forces, ang atong pangitaon class according to the principle of superposition of forces is we will just find the resultant vector. So meaning to say, kalimtan na nako, I will not analyze this problem by considering Fy and Fx, but I will just try to find the resultant force. Now, the simplest thing that we can use to find the resultant force in this case is to use unsa man nga method. So I'm hoping na ma-realize niyo na that the easiest way to do is to do the parallelogram method, because I will just do it like that, and I will write unsa man na siya sa taas. This is the mirror of F sub x. And then on the other side here, this one here, kinanobra de akong illustration, that is just the mirror of your vector F sub y, right? And then based on what we learn about the parallelogram method, we start, or we plot the resultant vector up until the point of intersection of the two mirror nila, or parallels nila, di ba? Kay parallelogram gud na siya, or nga method. So this is your resultant vector. Now, unsa may pasabot ana? That means to say that if I want to analyze this problem, I will only have to deal with the resultant vector, which is just one force, instead of considering Fy and Fx, two separate forces. So Rx lang di akong kinahanglan aning a case by the principle of superposition. And also in this case class, you notice no, you have two forces, Fx towards the right and Fy upward. The net force or the resultant force is here, kining R nimo. Mo na ginatawag nimo as this is your net force. Net force, or a more familiar na itong ginagamit is resultant vector. Sa itong previous na klase, no, resultant vector, or specifically since we are dealing with forces, this is called a resultant force. So I am hoping na these terms kay klaro sa inyo, parihara na siya pasabot class. Ang resultant vector lang nimo, general lang na siya nga term, because this vector could mean many things. For example, this could be like electric field, meaning daghan siya pwede ba, it could be velocity. But a more specific case applied to forces is resultant force. Okay, forces man ato ginadil. Okay, so if you encounter those things, they are just synonymous with each other with several na considerations lang or changes sa ilaang meaning. Okay, the same thing happens here. Basically, this is just the sketch of what I mentioned earlier. Now, of course, I failed to take into consideration no nga dapat na ay angle theta, because a vector should be directed na siya, a magnitude na siya direction. So, mao ni akong giingon ganina, if you have force Fx here, force Fy here, you have two forces, and by the principle of superposition, di ba, any number of force, which in this case kay duha, applied at a point in the body, it has the same effect as a single force, as long as that single force is your vector sum or resultant force. So in this case, as I've said, we have two forces. Masolve na to ning problem class by considering F here, or as I've said earlier, this is your resultant force. So syempre, more simpler siya in a sense that we are no longer dealing with two forces but only of one force, which is F in this case, or the resultant force. Okay? So another thing that we have to add from our previous learning is to, consider the fact that, I have mentioned it here, to consider the fact class that, take note that from our previous class, we are only dealing with the resultant vector, right? But I'm hoping you realize that there's something missing about it, We are only, because our answer for this are, for example, we have 100 Newton, the resultant vector is only 4. This is just the magnitude or the quantity. Now take note, resultant vector needs to have direction. So you will get to realize in this problem that we will add in our knowledge how to find for the direction of the resultant vector. So this is something that we will learn new sa ato ang discussion karon. But before going there, let me just review. This is basically just a review because this is what we have been doing for the previous month, solving for the resultant vector. Now, as you can see here, how many forces? We have force 1, force 2, and what method ang use ani class. So, I'm hoping it is clear to you that this is using the tip to tail or tail to tip na method. So, kay imo manggipang connect ang duha ka vectors. And of course, we've learned from our class that the resultant, just use black, starts from your origin up until the last tip of the last connected vector, which in this case is there. Now, of course, natin mga components, no? Ako lang ipang plot. So, maybe I'll use a broken line. So, nasa yung mga components, f1x. Ano na ito ginasolve actually? Kinahiwi siya, f1x there. And then f2x also, nasa component sa f2 vector, dira sa paman, kay, of course, y. Dira, no? For f1, and then f2, dapat siya ikuan, dira for vector f2. Okay, and so the resultant, syempre, kabalo na ta sa resultant, parehani look at the resultant. I mean, RY. So let's first deal with RY. Now, if you can see, the RY, of course, is just the sum of the Y components of F1 and F2. Ang imong RX, the sum of all the X component of your F1X and F2X. So this is not new to you because basically this is what we have been doing. All right. So I'm just going to maybe erase that a little bit because I find it like very gubot. But for now, let's focus with the discussion of the direction of the resultant or the net force. Okay, so I'm just going to iterate. Your R is something that we have already discussed. For example, 100 newtons. So we have discussed this already. However, the direction is something that we have tried to skip for the previous discussion. But for now, we have to talk about the direction. So taking the direction of your resultant vector is actually very easy, class. That is just, since you're allowed to take calculator, that is just the tangent inverse of your Ry over Rx. So basically, pag masolve na nato ang itong R anak class, syempre, unsa gani requirement, if you remember, to get your resultant vector R, you take the square root of your Rx squared, the sum of the square root of your Rx squared and Ry squared, right? So that is how you get the resultant vector. Now, if you are looking for the angle of that, you simply have to take this one. Mao lang na ang imong equation, class. So, syempre, I'm going to specify some points. Ry, this is something that you have already solved, right? And Rx is something also that you have solved. So basically, to get the angle theta from the previous na discussion, you just have to plug in these values. And you don't have to solve any more other things kay na-solve naman nato na. But there are some things na atong inote dapat diri. So for our discussion, in the same manner that we are measuring theta or atong angle in SPA, this should also be measured in terms of SPA, class. So kung makakita gani ka nga negative ang value, for example, negative ang gihatagan nga value, that means to say dili pa gyud na siya mao ang imo resultant nga direction sa imong resultant vector. Okay, sa imong SPA dili gyud ka kakuhag negative nga value sa imong theta sa SPA. Okay? No negative value of angle. So makakita mo sa example later ana unsaon nato atong buhaton. What we will do if we are getting negative value and where is this theta, angle theta. Okay? So in this case, class, ang imong resultant vector ani probably Ayaw na lang, ay dili na lang ako ipakita asa ang theta ani nga resultant vector, no? Dito lang ta sa example para mas masabtan ninyo. Okay, so we are dealing with this example. So as you can see there, I already had the solution because I know you can follow this one. Basically, this is what we are just doing for the previous month. So I'm just going to read the problem. You have 3 professional wrestlers are fighting over a champion's belt. The forces have magnitude F1 equal to 250 newtons, F2 is equal to 50 newtons, and F3 is equal to 120 newtons. So find the X and Y components of the net force on the belt and find its magnitude and direction. So the X and Y component of the net force, those are just referring to, unsa man na siya? That is your Rx and your Ry. So the X and Y components of the net force. Okay, and again, sa pangitaon, the magnitude and the direction. So this time around, we are now ready to solve for this direction because it's, as I've said in the previous slide, it's quite easy to do that. Now, the sketch of the problem is given in this manner, class. So look at the sketch in the left-hand side. So the force F1 here is this one. And of course, it's long because it's 250 newtons. F2 is directed towards the right, and F3 is directed downward. Now take note, we have 3 forces. Now, I'm just going to go back to the slide on the superposition of forces to iterate the point. Now, any number of forces. Now, in that example, to look at forces. So, kato siya class, masimplify daw to nimo siya by only taking, kaya na siya diri no, any number of forces applied at a point on the body have the same effect as a single force, equal to the vector sum of the forces. So, when we try to apply the principle of superposition here, take note, we have the highlighted no natay F1, F2, and F3. These are 3 distinct forces. To simplify this problem, isolve lang din nato ang resultant force ani. So we have to solve for R only, and that will simplify our problem. Kaya according to the problem, bahalag daghag forces, solbara lang ang R, kay it seems as though katong tanan nga forces, mura ratog isa ka force nga ga-act sa body, which is your R. That is basically the resultant superposition principle in Bisaya nga pagkaistorya. Okay, so ang atong buhaton na kabalo na ta na no, I just resketched the problem or the case here on the right hand side using tail to tip. So as you can see, F1 is in red, F2 is in blue, F3 is in green. So and the resultant vector is very small. You can see it's on quadrant 2. By the way, I did not scale that class ha. So if you do that, better to scale. Wala na akong scale kay dili kaya wala functionality of measurement in notability. However, that is your R there. Now, we have to solve of course for Rx and Ry. Kabalo na taon saon nato na. So, dili na ako na i-detail, ako nang i-run through class unsay nahitabo. But I would just like to emphasize this one. Gihatag ni sa problem na measured from this negative x pa saka sa positive y is 53 degrees. So, syempre, kabalo na tano, if we will deal with F1 cosine, that should be an SPA. SPA, tanan na siya. So, 53, ang atong pag-measure na sa atong F1 should be this angle, gikan sa yung positive x. So, that is why, if you notice, the angle is 127 because 127 degrees, mauna yung angle from the positive x up until this vector F1. Okay, so di na ako na-detail tanan. I-pause nyo yung video, i-try nyo yung solve. Na yun, ay check lang din ninyo. So for F1x, ako yung negative 150.45. F1y, ako yung 199.66 newtons. Now for F2, kinisya no, this is just a matter of analysis. Take note, F2 is towards the positive x-axis. Naagid siya galay sa positive x-axis. So sa inyong huna-huna, dapat wala gid mo makuha nga y component ana kay naagid siya sa x-axis galay imong F2 kanang green na vector dita blue na vector. So F2, the cosine of the angle of that class, syempre standard position, that is just 0. So I'm hoping this is making sense. The cosine of 0 is 1, therefore F1x is 50 newtons and the sine of 0 is 0. Now this is 0. So that's why F2y is 0, and that makes sense nga 0 ang y ana kay your force 2 lies exactly only on the positive x-axis. Okay? Proceed ta sa, we are on 20 minutes. So padayon to sa F3. So the same story with F3. You try to look at F3, you also noted that F3 lies exactly in this one class na kining green nga vector bitaw. On the y-axis, good. So you should be expecting na 0 gid na ang fx nimo ana or x component. Okay, so if you try to solve also of the angle of that, syempre, start from here up until this one that is 270 degrees. SPA gihapon ta. So 270 degrees, so the cosine of 270 degrees, if you try to calculate and recall from the unit circle, that is 0. So that's why it's telling you that the f sub x, f of 3 sub x is just 0. And that is correct. Or dapat mao gyud makuha ninyo because wala na x component class kay naa gyud na siya galay sa imo ang y-axis. And then the sine of 270 is -1, so that's why you are getting the f3y is -120n. Now to find our x, of course, kabalo na ta, we just have to take the sum or add all the x components of the three vectors, which are f1, f2, and f3 respectively. And of course, for ry, just take the y components of all the vectors. So adding that one, you have rx -100.45 and ry 79.66 newtons. And how to get the resultant vector, we are all very familiar with this one already, and I'm hoping this is clear. We just take, kinsa maganing nga term na akong gina-highlight karon, that is your rx squared plus, kinsa, this is just your ry squared. And once you calculate that one class, you should be able to get R is equal to 128.20 newtons. Now, the thing that we will add is the direction. Diba? Kay kabalo naman tao, nabalik-balik na ng resultant na to. So, we will take the direction. So, do take note that in getting the direction, ang atong buhaton ana is this is the formula of getting that one. That is just this tangent inverse of ry over rx. Kung na lang yun ang timan i-class. So you write tan inverse, and ry nimo is this term, 79.66 newtons, and your rx is -100.45 newtons, and your calculator initially will give you -38.42. And how will you make sense of that? By the way, kung dili mo kabalo sa yung calculator, no, mag-tangent inverse, pangitaalan nyo tong tan, nga key dito class dayon shift, then katong tan, butang na siya tan to the -1 dayon. Okay, so just try to experiment with that. But however, I would like to focus on this angle. Now, what is given from the formula of theta is equal to tan inverse of ry over rx is -38.42. Now, take note, your resultant vector is this one in blue. I'm hoping that is clear to you, no? Nakanang blue. Now, where is -38.42? Kini siya class. Kini gikan ani padulong ana imong vector kay negative manggod siya. So that is your -38.42 degrees. Mauna siya dira. Mo na direction niya sa imong vector. If measured from, of course, maganing negative siya, no? Kaya gi-measure nimo siya sugod sa negative x-axis. Pero since we are dealing with standard position, what we want is, of course, from the positive x going to the resultant vector r. Padulong ana class. So mauna ang appropriate na to nga angle ana if this is 38.42. The negative here, do not get confused. The negative here only specify the manner of measurement. So meaning to say, nagsugod na siya measure sa imong negative x. So if we are going to express this in standard position, if this angle here, kining gamay nga angle nimo diri is 38.42, then the other angle is equal to 141.58 degrees. So kiniday siya nga angle 141.58 degrees. Okay, if you add that two angles together, it will result to 180. Which is the angle for a straight line. Kaya straight line na ba na mga form mo, ana ba? Okay, so I'm hoping I'm making sense there. So the angle, okay ra gyapon if kinini niya ibutang if kini inyong ihatag sa ako negative 38.42, butang ilang po siya label from from the negative x-axis. Manang nag-negative 38 na siya. So this is, if this, the upper portion is how you will report your answer, I'm fine with that. But I do encourage na mag-SPA ta para dili ta maglipog. Parehat tatanan og result ba. So SPA, in SPA, that is 141.58 degrees. So I know this is just one example because it's very easy to get the direction. You just have to remember this one, that the direction theta of the resultant vector is just the tangent inverse of your ry over rx. So always good na kana good yung form class. So as long as you basically more good, we perform everything that we have learned from the previous months on how to solve for the resultant vector and just plug in on your calculator this one, tan inverse of ry over rx, and you will get the angle theta of the resultant vector. Now, what is the implication of the problem? Now, based from the problem class, although na kay tulo ka wrestler no nag-apply og different forces F1, F2, F3, ma-solve the inatotor, it seems as though by the principle of superposition of forces, nga kinirang, murag isa lang, kumbaga ba, murag siya ma-solve na tong problem nga isa lang ang force nga ga-act niya, which is this force here, which is the resultant in this case. So, mauna ang application sa atong superposition of forces. Now, that is very essential ug dapat pasabtan ninyo because most of the problems in physics, we have to simplify by using this principle. Or sa pinaka-yano nga sa pinakadali nga pagka-istorya class kay, sulbaron na din nato ang resultant force o kato atong gamiton. Dili na ta magtatag sa og analyze sa isa-isa nga force. So, mao lang na ang point sa superposition of forces nato. Now, I want you to recall before going to Newton's law, first law, it's 27 minutes. I will try to finish this in like maybe 35 minutes or 40 minutes. I would like to recall your game previously. Diba? We had a game of building towers from paper cups. And then one of the things that you realize is that to win the game, there must be a balance of forces in terms of how you pull the strings or the yarn in that case. Now, let's apply that one, but basically we'll talk of the same concept, but let's put it in a different context. Now, as you can see in this illustration here, I think this is a soccer ball, right? So the soccer ball there, let's deal with the first case class when the forces are, okay. When the friction, which is a force, ako na siyang i-denote by F of F sub F, and F applied are equal. So when they are equal, for example, if I will try to apply a force, let's make a bigger one here, mag-apply kong force ani class, ako na siyang sipaon kumbaga padulong dira. So that is my F applied, and then also, in a different color, I'll use blue na pod since that has a contact with the ground na ako'y F of friction and a class. So we are dealing with the first case where the F applied and F friction are equal. So equal sila . So unsa may mahitabuan niya? So first question, does this mean that the forces are balanced in this case? So, balance ba ang force ni mo, anak? Sige daw, tabaga daw. Balance? Yes, they are balanced. So, F applied, parihaman, they are equal. So, unsa may implication gani nato ani? In this case, ang implication nato ani in terms of the motion of the object is no motion. Okay, parihaman imong magnitude sa imong gi-apply nga force o imong magnitude sa imong friction in that case, dili siya molihok. Butang talang ang gi-apply ni mga force. These are not realistic number. Just for illustration or explanation, 100 newtons. F friction nimo is 100 newtons gihapon. So syempre wala pa nay lihok ang mahitabuan na nimo class, no? Sa imuhang object. So implication, no motion. Balance ang force gihapon ana. Now, let's try to deal with the case where ang imuhang kuan class, imuhang bola, imong soccer ball kay galihok na siya initially, meaning napalihok na nimo siya. Now, at some point, naata ibutang talang nagalihok na siya, no? So, kaning F apply diri, case B, already moving, para ma-distinguish na to. So, galihok na siya. So, ang case A kay wala pa maguni siya galihok, no? So, not stationary first. Nag-ana siya. Stationary first. Okay. Now, the case B where it's already moving, meaning gisipa na nimo siya, naglihok na siya. So, when F applied niya, class, F applied dira, no? Dapat red para consistent. I'm going to use red. So, the soccer ball is already moving and you're applying a force. F applied towards the right. And also, since there is still a contact with the ground, naasab kay F due to friction area. Now, take note, since this ball is already moving, unsa may mahitabo? Unsa man ang characteristics sa iyang forces ani, are they balanced or not? So, again, no, akong klarohon, sa case B, galihok na siya. So, ang F applied ni mabutang talang nimo is 200 newtons. And then, ang F friction nimo is 200 newtons. But since it's already moving, the forces are still balanced gyapon. Pareha man sila, 200 towards the right ang isa, 200 towards the left ang isa nimo. Meaning, 200 towards the right ang F applied, 200 towards the left among F friction, they are still balanced forces. Now, implication gani ani, wala by motion ang mahitabo. So, dili kita may wala motion. Kani ana ganita in the first place na naglihok na siya sugod or already galihok na siya. So, ang implication ani is moves at a constant velocity. So, pasabot mo ning kung kadumdum mo itong mura ko og kuan, mura ko clown sa inyo utubangan nga galakaw-lakaw nga in this case class, constant kumbaga kung natawo pa ni siya, constant lang ang iyang paglikang. Dili siya magkapaspas, dili siya magkahinay. So, whenever you have a balanced forces and it's already set in motion, it moves at a constant velocity. And again, the implication of constant velocity, if you remember, the acceleration is zero. Because again, acceleration is just your change in velocity with respect to time. Sorry, nag-dt na ko. With respect to the change in time. So, syempre, change in velocity is velocity final minus velocity initial all over the change in time. And if there is a constant velocity, it implies that, this implies that Vf is equal to Vi. Kaya man gabagoong velocity, constant man. So, these two terms here will just be zero. So, mauna nga, if you have constant velocity, zero na siya, your acceleration will in turn be zero. Meaning to say, sa Bisaya pa, kung zero ang acceleration, wala siya nagkapaspas, wala siya nagkahinay. So, ang implication, it's either, this is just a review from our previous discussion, if naka-balance forces, either yun na siya mulihok, or maglihok na siya at a constant velocity. Dili magbago ang kakusgon, parihara gyud siya permente. Okay? So, I think we are now ready to jump to the first law of motion ni Newton. Now, consider this case class. So, I know we have all played probably sa kanang mga arcade, no? Mga ingunani natay, so ganitawag na to, ana. Kanang, sa ganitawag, basta kanang nakay table ba, tapos na air bitaw, tapos nakay murag pack diri kanang plastic, tapos inyo habitang ikuan katong murag basta kay kaila mo ani. Ang point ani niya class is if you have this material here and then you try to move that one, the first case is you're just trying to move it on a table. So somehow the table medyo dako ang friction ana niya, kay rough man na ang surface ana. Now you will notice the distance covered upon applying a force is also smaller. Now, let's move to the case, the same gihapon, kaso, instead of doing it on a table, we are doing it on a table of ice or sa ice na to class. So, syempre, this one is slightly lesser ang friction niya compared sa table. So, ang manotisab nimo sa iyang distance nga ma-slide or na-move niya nga distance is slightly larger sab, kay lesser man ang friction. Up until the case class where hockey dito, air hockey. Up until the case where kanang makita na to sa mga arcade no, nakabantay mo na, agi na siya mga buslot-buslot kay manggawas man dito ang mga air nimo. Kay para ma-minimize ang friction. Meaning, dili kayo mo touch in contact ang imuhang pakiba na imong material dito sa imuang surface. Mo nang naay mga buslot-buslot magawas ang air dira. Para murag somehow mag-levitate siya gamay. Para ma-reduce ang friction. Now, in this case, kita pa ta from experience, if ka-experience ta, ani, nga, layo kaig malagputan, gamay lang gani nga force, hastang layuan na ang i-cover nga distance ani niya diri. Diba? Kaya mga man idula na to, kay papaspasay ba? So, ingon na siya nga case class, so ang nahitabuan na niya diri, the friction ni mo dira nga force is already very, very small. As in, gamay na gyud kayo ang imong friction nga force ani nga case. It is very, very small. Very, very small. It's very small in that case. So, unsa may na-notice na to, no? Balik ta sa atong na-notice ani. When there is still a friction very great, common sense will tell us nga gamay lang yun ang matravel ana nga distance. Magagamay ang friction, magkadako ang distance. Magkagamay pagigay ang friction, magkadako gyud kayo ang iyang distance. In fact, kung imo ning hunahunahon bitaw class, this case, see, whenever the friction is zero, kung ma-zero na gyud nimo ang friction bitaw ani, ang kining imuhang, as long as you have an infinitely long na kanang table, ang kini bitaw imong paki, kini siya class, kini imo ang material diri will travel continuously without stopping. Magpadayo na siya. Once you have set this in motion, nag-atag kag force ana niya, applied force, as long as walay friction tinud anay ang surface og infinite bitaw na imong table, taas kay imong table ba, dili gyud na siya muundang og travel, padayon na siya. Mag-travel na siya constant nga velocity. Ana niya karon. So mo nay point na akong gusto ipakita ninyo dira ano. But before going there, yeah. Okay. So, yeah. Ato sa nilang i-discuss no, kaya nakita na akong time 37 minutes naman di ay. So what generalization can you give based from the demonstrated motion? So, sige, tabangan ta magtubag ana. Firstly, when your friction approaches zero, kung sa mahitabo or ma-equal na gyud siya sa zero sa ato nang ginaingon, the material, in this case, kanang sa atong air hockey, will continue to move. Padayon siya lihok. Di na siya muundang ba? Kumbaga. But let's first deal with this case. First, A. Now, sa first case A class, kini ang akong gusto nyo na naon. If F applied nimo, tapos naman ay friction, no? Siyempre, naman ay friction dito, opposite yun ang friction nimo. So, if F applied and F friction are balanced, meaning equal na silang duha, unsa may mahitabo ana nimo if balance ang F applied og F friction aning case sa imo ang pack on a very rough nga table, mulihok man na siya or dili? No motion. I'm hoping this is clear sa inyo kay syempre stationary pa man imong pack, no, iga-apply kag force, pero it so happened that the force that you applied is also equal to the force due to the friction, walay lihok ana niya. And that is consistent with what we talk here. Kung kanumdo mo, yung F applied, F friction, once that's stationary, your ball is still stationary, di basta no motion gina siya class, basta equal or balance ay imong forces dira. So in the same manner, diri sa imong pack, once your F applied is equal to the F friction, syempre, unsa may ginaingon na the forces are balanced, walay lihok niya. Okay, maunay mong nakita dira. But once you have set this already in motion, just like in C, dito sa C, once nga galihok na siya class, just like in C, unsa man atong button. So ato na pang ibutang F applied, tapos F friction, no? Ang imong force due to friction. So sa case C, just to make distinction from case A, kay galihok na na siya. So it's already moving, but in this case, unsa man ang nahitabo, how will you characterize the forces sa imong F applied og F friction? Na take note, ako nang ginaingon, no, once mawala ang or very minimal ang imong friction ana niya class, ang mahitabo ani kini siya will move at a constant velocity v. And it will continue moving at that velocity class. Di siya muhinay, di siya makusog kung wala ang friction. So how will you characterize the forces in this case? So the forces still are balanced in this case. Kaya nagpadayon man siya move with a constant velocity. Akong tangag note diri no nga constant velocity. So balance ra gyapon ang forces ana niya. So take note, before moving or katong pag gusto nimo iset in motion, balance ang forces niya. Kung stationary pa siya, balance ang forces niya ato. Katong naglihok na siya, padayon siya glihok, balance ra gyapon ang forces niya ato kay wa man siya ga-accelerate, wa pud siya nagkahinay. So try to remember that because that will be helpful in trying to understand the first law of motion in Newton. Now, again, what generalization can you give based from the demonstration? It is this. Once a body has been set in motion, just like in the case of what's this? Case 3, no net force is needed to keep it moving. Now, if you remember from the previous slides, no net force means a net force unsa ganit nato na resultant force, di ba? So resultant force na siya. So but pasabot unsa may other statement ani? Once a body has been set in motion, particularly this case C, no resultant force is needed to keep it moving. Moingon but pasabot, the resultant force can be equal to 0 or balance na ang forces nimo. So, once a body has been set in motion, no net force is needed to keep it moving. Meaning to say, no resultant force, meaning the resultant force could have a value of 0. Murag yung na siya ba, kung ang resultant niya class, kung ay force diri, padulong dira F1, F2, it doesn't have to be nga mas dako ang F2. Diba? Padulong man ang motion nato diri, padulong man na siya diri It doesn't have to be the case where F2 should be greater than F1. Dili. Bahala pag equal na silang F1 o F2, basta it's already set in motion, it will continue moving. Mao nang bahalag imong resultant vector or resultant force nimo kay equal na siya sa 0. Or meaning to say there is no net force. It will still continue moving, just like the case of your air hockey there. Okay? So I'm hoping this is somehow clear sa inyo. Now, once a body has been set in motion, this is what we can generalize from that case. We don't need any additional force to keep it moving. Magpadayon na yun na siya, just like your air hockey. Okay. So, we are now ready to somehow understand the first law of motion of Newton. This is a familiar version that I know you're familiar with this one from your elementary probably or from your previous physics classes, that an object at rest remains at rest and an object in motion remains in motion unless acted upon by an unbalanced force. Now, why I said I tried to discuss earlier about balanced forces, because let's try to deal with this object at rest remains at rest class. So this is the case particularly of A, kining A nimo. I know this is moving based from the illustration, but let's just say na you have this object here. It's still at rest. That object will remain at rest unless it's acted upon by an unbalanced force. Unbalanced force ang kinahanglan. Now take note, in the case of A, the force applied is equal to the force of friction. The force is balance. So kung balance ang imong force, it will remain at rest. Mauna nga dili na siya mulihok kay balance man ang forces nga naa dira. I'm hoping I'm making sense. Kaya balik ko na to, no? First lang ta nga statement, pwede mawala. An object at rest remain at rest Kinidan, i-red na lang ako ni B, i-pink. Unless acted upon by an unbalanced force. Maunang case imong A nga since the forces are balanced, it will remain stationary. Kaya giingon sa force, giingon sa law, unless acted upon by an unbalanced force. So, ani nga case, rest padayon na gina siya rest. Okay? So, I'm hoping it's the first statement there, ang rest remains at rest unless acted upon by an unbalanced force is already clear sa inyo. Secondly, let's try to deal with this one. An object in motion remains in motion unless acted upon by an unbalanced force. So that is the case for the C here. KC, lang tawa imong KC. Ang imong KC, once na balance na ang imong forces, ang imong F applied ug F friction, mag-balance na sila. We knew from our previous discussion that it will continue to move at a constant velocity V. Meaning to say, magpadayon na siya lihok forever with a velocity V as long as nag-balance ng two forces ni mo ana. And it will not stop. Sige, ingon sa atong law. An object at rest remains at rest unless acted upon an unbalanced force. So that is the case for A. Meaning to say, as long as balance imong forces, di gyud na siya molihok. The case of C. Now, we are dealing with in motion, no? An object in motion remains in motion unless acted by an unbalanced force because, as you can see there, balance magyapon ng forces ato niya class. Since the forces are balanced, it will continue to move with a constant velocity V. Now, magpadayon gyud na mao nang giingon niya diri. Once it's in motion, it will remain in motion unless, marabi tawag sa Bisayan sa mga unless, until, marabi tawag na ay unbalanced force. So, unless, whenever balance pagyapon ng force anini mo class mong KC, it will continue to move with velocity V. It will not stop moving. Continue na siya mag-move. Now, according to this statement here, it will remain in motion unless, meaning to say, mo-stop lang siya og motion kung naay mag-act nga unbalanced force. Mo na nakita ni mo diri, since balance ang forces man niya, magpadayon na gyud na siya lihok with constant V. But if unbalanced na imong force class, in this case, for example, unbalanced nga force means nga if you take the sum of two forces, let's say, for simplicity, F1 tapos F2 ni diri, kung naay mag-act na unbalanced force ana niya, butang talang no mabangga na siya og kuan diri kanang butang talang naay mass diri nga iyang mabanggaan. Syempre the force will not be unbalanced because there will be a force trying to push this backward. So eventually mo stop na gyud na siya or mo halt siya ba, mo change iyang velocity taman sa mo stop gyud siya. So mao nang ginaingon niya diri nga unless naa kay unbalanced force, magpadayon gyud nag in motion ang imong object. Okay? So, sa ganito ginaingon niya, an object at rest, magpadayon siya at rest, ug ang object nga galihok, padayon po na siya molihok unless naay ga-act niya nga unbalanced force. Mauna nga nakita ni mo diri, dili siya molihok, ngano gani di siya molihok, it remains at rest sa case A because the forces are balanced. Your applied force here and your friction going there are the same and balanced, so it will remain at rest. Diri ngano ganing di pud siya muundang, meaning it will remain in motion because your F applied and your F friction are balanced, means to say it will continue to move with a constant velocity. So the solution there para maundang nimo siya or mapalihok nimo siya, in this case mapalihok ni o kining KC kay galihok naman ni Noso mapaundang, Bisaya na gid ba? You need an unbalanced force to act on your system. So mao na siya dapat. So I'm hoping na klaro ninyo na, no? And another version which I tend to advocate for you, mas maganahan ko ning version, mas physics magud siya para sa ako. This one, this is the statement of the first law. A body acted on by no net force. Mo yung tag no net force means, unsa ganina siya? Balance. A body acted on by a balanced force moves with a constant velocity. This is one of the things na we discussed earlier, which may be zero. Sabot pasabot, pwede siya, mauning ginayon na ito na stationary siya. Kay zero man yung velocity, wa siya galihok ba? And zero acceleration. That means to say, class, by the way, your resultant force are, resultant force man nato na, no? Resultant force that is also represented in physics as the sum of F. So they mean the same thing. Or sometimes, parihara na siya sa, inasulat sab na sa uban nga F net. Okay? Now, in this case, kung akong isulat ang first law, the sum of F net is equal to 0. Dili dahil ayaw sa na kay murag maka-confuse na sa inyo. So kana lang, try to understand that the resultant vector, in this case the resultant force, is sometimes represented as the sum of F or simply F net. So they mean the same thing para lang to avoid confusion on the use of these terms sa physics. Okay, so for the next, I think we will have this for the next discussion ng atong inertia, and yeah, we will end with inertia, and then after that is unsa may sunod ana gani. Apa to isa na class moment na yun ta. So this is the task for your pre-recorded or asynchronous na klase karon. So I will not be giving a personal milestone, or maybe later wa pa na ako nabuhat ang personal milestone. Just check your Google Class and try to answer it in your vacant time. But just to test kung nakasabot ba mo sa concept. Okay, so I will be seeing you then for raw, I will be seeing you on Wednesday for the lab. And for the other, like mu, lambda, and omicron, I will be seeing you on Thursday for the lab. So do not forget to bring your, say tawag ani, lab gown.